Okay. So, guys, we've hit the halfway point of this chapter. I said that in the textbook, this is like 2 chapters. First half is adding and subtracting, so we've done that, right? And the only thing that we didn't cover is a few word problems, which I'm going to wait till the very end, the last class before the test to do that, right? So we've gone halfway through. You guys know how to add, you know how to subtract. It's pretty straightforward. Usually the errors that students make is they start forgetting things or start mixing up things towards the end. Yeah. Yes, Ava? Okay. So today, we're going to start getting into multiplying and dividing. Now today should hopefully be nothing new, but more of a refresher of what we did in the exponents unit. Right? So today we're looking at multiplying and dividing monomials. What does monomials mean? How many terms? One term. And that's what we were doing in the first chapter. It was just multiplying one terms together and applying the exponent rules. So it's going to refresh you of those rules. The next day we're going to look at multiplying binomials with more than one term. What do you do there? All right? So in the first chapter with exponents, you had to multiply 2 variables together. And do you guys remember what this equaled? No.
3. I don't remember.
Right?
5.
Right? So what did this mean? This meant that x times x times x is the first one. Second one is x times x times x.
Oh, not this. No.
So what? The base stayed the same. And what's the exponent? 5. Right? So if you are multiplying variables, we use the exponent rules to multiply the variables. And what the rule is we add. Right? Now, the one add-on for this chapter is usually we didn't have coefficients with the variables, with the exponent section. So now, if we have exponents involved, and we go, hey, I go 5x cubed times 4x squared, we apply the exponent laws as we do for the for the variables. So it's still going to be x to the power exponent 5. Then we just multiply the coefficients just like you used to, right? So what's 5 times 4? 20.
I thought we were done with these.
Right? So you multiply the coefficients, the number.
So you're multiplying the numbers and adding the
exponents, right? So you're applying the exponent law. So the exponent law said, hey, when you're dealing with variables, we add the exponents, right? And multiplying numbers, that hasn't changed from what you did in elementary school. Just multiplying the numbers together. But you have to go back to the exponent laws, right? So now let's do one more question before we move into the examples. So if I had, I'm not sure how much you remember, this, can we combine these to a single power?
No.
Why not?
Because they mean different things.
They mean different things. The bases are different. So we can only multiply the terms where the bases were the same, right? So they just remain as is. Okay. So let's look at example 1 here.
Wait.
could it be 6xy
Hmm?
or 8xy?
Sorry?
How do you?
Oh, he wants.
All right, give me 1 second.
What did that word say?
Exponent.
Exponents.
Could
Exponent.
it be 8xy for the first one?
Yeah. So first one, you multiply the coefficients. There's 2 brackets touching each other, just means to multiply. So 4 times 2 is 8. Then you deal with the variables. You apply the exponent rules. Yes.
Do you put the xy or can it be yx?
It can be either way. So we can't combine these variables together because they're different bases. Now, it can be xy or yx. The math convention is to do in alphabetical order. But both are technically correct. One is just a convention. So we tried to write them in alphabetical order. X comes before y. right? But either way,
Lose mark.
no, you will not lose mark. Right? You could go 8yx if you wanted to. Okay, let's do B.
Oh, it's -7 yeah.
Yeah, -7. Multiply the numbers together. -1 times 7 is -7. Now we deal with the variables. X times x, what is that?
But don't you add them? Oh, it's
Yeah. X, the bases stay the same. We add the exponents.
oh, I got that 1.
2. 1 plus 1 is 2. All right? Okay. Okay, we have a number and a number. When we multiply those two numbers together, what do we get?
+6.
+6. Okay. Moving on. We have an x base. We have an x base. We multiply those together. The base doesn't change. So the base stays the same. No. What's the rule? 5. We add the exponents. 2 plus 3? 5.
And then is the second one? What about the y?
So it'd be y3.
y3. The base stays the same. We add the exponents. Right? Okay. Let's skip D for a moment. We'll come back to it. Okay? Okay. So, now, if we were dividing, so we had x to the 5 divided by x cubed, or remember that could be rewritten as x5 or x3. Division is the same thing as a fraction. From the first chapter, the base never changes, but what's the rule for the exponent? Subtract. Adding, multiplying was adding, dividing was subtracting. So what's our exponent here?
Would it be x2?
Yeah, x2. Right? So we use the exponent rules once again for the variables. And the rule is we subtract the exponents. Okay. Now if we have
I didn't see what the were.
exponents. Now if we change this to put coefficients in front, so we change it to say 8x to the 5 over 4x cubed, we use the same thing for the exponent law. And what do you think we do with the numbers?
Or divide them.
We divide them. So what's 8 divided by 4? 2. So we do what we've always been doing. We divide the coefficients.
Can you just write numbers?
Sure. Right, but you should know what the word coefficient means. Right?
I'm gonna forget that.
It'd be like a multiple choice question. Hey, what's the coefficient of this thing?
That's-
What's the variable? What's the exponent? Remember that in the first test? Okay. So, going over here, let's go to, we'll do D last. There, let's go here. We have numbers. What would it be? 4 divided by 2? 2. All right. Then we have,
Just be 2.
oops.
It'd be 2x. It'd be 2x.
All right. Oh, you guys are ahead of me. You have an x and x. The base doesn't change. What should the exponent for the x be?
1.
1.
But you don't write.
Well, we don't need to show it.
It's just
All right.
2x.
So just 2x. Okay. Next up, we have our numbers. We clean up our numbers. What does that give us? Close.
2.
-2. All right. We look at our variable. We have an x and an x. So our variable doesn't change. What's the exponent?
1.
1. right? We have a 2, and you have imaginary 1. 2 minus 1 is 1. All right. Yes, Renee?
And then y3?
Y to the 3. Y to the exponent 4. And y to the exponent 1 here. 4 minus 1? 3. No, Ava?
I'm so lost now.
So the bases never change. All you're doing is subtracting the exponents. Well, this is a 2, that's a 1. 2 minus 1 is 1. You don't need to show the 1. You don't need to show a 1. Right? 4 minus 1 is a 3. Okay. So now, I like to write things as fractions, but these statements may come like this. They're just as equivalent. Right? You can, if you're comfortable, you can do it like this. Or you can just rewrite this statement as a fraction. The term after the division goes in the denominator. Okay. How do we clean this one up now? So we have a number on the bottom.
That says to nothing because it is 3 times 0 is 0.
So it just remains as is, right? So like the number in front on the top is a 1. It says 1/3. So we're not going to do a decimal here. So we'll have a 3 at the bottom of our fraction here. Okay. So we have our x and our x. Our x's don't change, the variable. And what is our exponent?
2.
2. 3 minus 1 is 2. Okay. The last one, we have a y and nothing on the bottom. So what would we write down? Just a y. It has nothing to combine with, so it just remains as is. Okay. This is a little bit not so nice one. How would this look like as a fraction? Can we look at this and see what the fraction would look like before we cleaned it up?
Couldn't you make the 1/2 a half?
0.5, you mean? We could, but if the number is given as a fraction, we want to keep it as a whole number. As soon as you go to decimal, so you start introducing rounding here, right? So I'm going to do this slightly different. So the first fraction looks like that, right? I'm going to write this down, right? So remember, and I'm going to write the second one as a fraction as well, right?
Why
So
did you get rid of the 1?
I put a 1 down. Oh, on this? Because we can have the 1 in front, but it doesn't help, doesn't mean anything, right? Just clutters things up. All right? So remember, we don't divide, but we multiply fractions.
Oh, wait, would you flip it?
We would
No,
flip.
it.
You flip it. Right? Like over here, it was a little bit easier. Is we just said, hey, let's just move this to the bottom. All right? This means the same thing, but it becomes a little trickier when we have already a fraction here. Right? So this, now we multiply the tops together, is x cubed on the top. What's on the bottom? 6x squared. Okay.
Oh, this got, wow.
Takes time. All right. Okay. Now we have x's on the top, x's on the bottom. We need to clean this up. The number has nothing to be simplified, so that just stays as 6. All right? And the x gets what exponent?
X5?
No.
Are we dividing or adding right now?
This symbol means
But
divide.
then we had to like flip it and then we were.
Yeah, but you're looking at what your current version is.
Just x
So X,
So-
just X?
Just x. We subtract. Division line here. 3 minus 2 is 1. Right? so just 1. All right. Now, I skipped the d up here. It's actually easier now that we've seen, hopefully, all of this. So we have 15x times x cubed. I'm going to rewrite it so everything's at the same level. And I go like this. All right? So,
Do we have to?
no, it's a time symbol, so we don't need to flip it, right? We only flip when we're dividing. So, we multiply the tops together when we have fractions. So what would the top be?
15x2.
15x2. We add the exponents, right? What's the bottom?
Just
3. Okay. Now we can clean this up. We have a 15 over 3. Can that be simplified further? Yeah. 5. 3 goes into 15 5 times. So this is equal to 5x squared. All right. And that's it.
Interesting.
All right. So you got to remember your exponent rules.